Hi everyone, in Algebra 2B. Today we're going to be going over your questions on lesson 106A. We're going to start on number 1. So it says, Jerry started a used parts establishment. He marked up the items 30% of the purchase price. If one item sold for $715, what did Jerry pay for it? So this problem comes from lesson 101, where we have the selling price is equal to the purchase price plus the markup. And in this case, they tell us that the markup is a percentage of the purchase price. So we have the selling price is equal to the purchase price plus 30%, because it's 30% of the purchase price, so multiplied by the purchase price. They tell us that the item sold for $715, and we are trying to find the purchase price. So if I add the PP plus a 0.3 PP, I would get 715 is equal to 1.3 PP. Then when I divide both sides by 1.3, 715 divided by 1.3 gives me a purchase price of $550. So again, that came from lesson 101. So if you had your notes for that, you could just flip there and that would have given you the equation. Now looking at number 2, it says a plane could go 6 times as fast as a small car. Thus, the plane could go 1,200 miles in only 1 hour less than it took the car to go 250 miles. Find the rate and the time of the small plane and the rate and the time of the small car. So when it says the plane could go 6 times as fast as the small car, that means the rate of the plane is going to be 6 times the rate of the car. Then it says the plane could go 1,200 miles. So the distance of the plane is 1,200. In only 1 hour less than it took the car to go 250 miles. So the distance of the car would be 250. And then we'll look at the time. So it says the time of the plane in 1 hour less than the car. So it would be the time of the car minus 1. Now we know our equation for distance and time for distance, which is rate times time. So this would be RPTP equals 1,200. And then over here we could do RCTC equals 250. Now if you look, I have RP and then I have TP here. So I'm going to plug that in. So it would be 6RC times TC minus 1 equals 1,200. You're going to distribute that. So that'd be 6RC minus 6RC equals 1,200. And we know what RCTC is equal to because we have that right here. So I'm going to take that and plug it in. So that would be 6 times 250 minus 6RC equals 1,200. So 6 times 250 would be 1,500. So I'm going to move this to the other side by subtracting it. And that would give me negative 6RC is equal to negative 300. So when I divide both sides by negative 6, I would get 50. So RC is equal to 50. Now I'm going to take that and I'm going to plug it in right here. So that'll be 50 times TC equals 250. So if I divide 250 by 50, I get TC is equal to 5. And now I have to solve for TP. So TP is equal to TC minus 1. So that would be 5 minus 1. So TP equals 4. Then I'm going to take the RC and plug it into there. So that would be RP equals 6 times 50. So RP would be equal to 300. Okay, and that concludes number 2. Now moving on to our next word problem, number 3. It says the nearest stagnant river flowed at only 2 miles per hour. Harold's boat could go 56 miles down the river in half the time that it took to go 80 miles up the river. What was the speed of the boat in still water? So it says the current or the water speed is equal to 2. Then it says that the boat could go down the river 56 miles, and it could go up the river in 80 miles. Then it says something about time. It says it could go 56 miles or go down in half the time it took to go up. So the time down would be half the time up. And what I would do here is I would get rid of that fraction. I would actually multiply this whole thing by 2. So that would end up giving you an equation of TU equals 2TD. So I wouldn't use the fraction there. I would definitely multiply that. So now I have 2 equations. I have my downstream equation, which is going to be B plus W times TD equals DD. My B I don't know, but I do know my W is 2. My TD I don't know, but my DD is 56. You're going to distribute the TD, so that would be BTD plus 2TD equals 56. Now my upstream equation is going to be the same thing, except it's going to be B minus W times TU equals DU. So it would be B minus 2 times 2TD equals 80. And I'm going to distribute the 2TD. So that would be 2BTD minus 4TD equals 80. So now what I'm going to do is I am going to eliminate the, you can either eliminate the TD or the BTD, it doesn't matter which one. So if I multiply this equation by 2, I would get 2 BTD plus 4TD equals 56 times 2, which is 112. The TDs would cancel, so I would have 4 BTD is equal to 192. Divide that by 4, so BTD is equal to 48. But I'm trying to solve for just B. So then what I would need to do is I can plug this in to solve for TD and then solve for B. So I can take this 48, and that would be 48 plus 2TD equals 56. Subtract the 48. So that would be 2TD equals 8. So therefore TD is equal to 4. And then I'm going to plug that into this equation here, which is B times 4 equals 48. So that means the speed of the boat is going to be equal to 12. Now moving on to number 4. The temperature of a quantity of an ideal gas was held constant at 500 degrees Celsius. The initial pressure and volume were 700 and 500 milliliters. What would the final pressure be if the volume were increased to 1000 milliliters? So for this equation, it's usually P1V1 over T1 equals P2V2 over T2. But because it says the temperature is held constant, we actually don't need the temperature in this equation. And I'm going to plug in the initial pressure, which was 700, the initial volume, which was 500. We're trying to solve for the final pressure when our final volume was 1000. Divide both sides by 1000. So I can do 700 times 500, divide that by 1000, and that gives me that X is equal to 350. Now we're going to look at number 11, and this one is going to be based off of the lesson where we talked about graphing a parabola, which was lesson 100. So I'm going to pull out that equation right there. So what we want is we need to complete the square to get an equation that looks like this so that we're able to graph it. So I'm going to start by putting all the x's in parentheses because I want my equation to look like that. So I'm going to do y is equal to negative x squared minus 2x, then minus 3. I have to factor out the minus sign because you can't complete the square when there's something attached to the x. And now you're going to complete the square. So half the term attached to x would be plus 1. But when I square the plus 1, it would be just 1. Remember, though, that this is actually a minus 1. So when I go to do the opposite to the outside, this is actually a minus 1, so I'm going to add 1 to the outside, meaning that my outside number is going to become negative 2. Now, this right here tells me that my graph is going to go down, opens down. This is going to be my axis of symmetry right here, axis of symmetry. So you're going to set that x plus 1 equal to 0, and that gives me an axis of symmetry of negative 1. And this right here is going to be my vertex where I'm going to start on the axis of symmetry. So at negative 1 is where you're going to put your dotted line in, like that. Then at negative 2, you're going to put your dot for your vertex. Now to graph your points, you're going to go over 1, down 1 in either direction. Then the next point would be over 1, 2, down 1, 2, 3, 4. And this should be what your parabola would look like. It's going to open down because of the minus sign, axis of symmetry at negative 1, vertex at negative 2. Okay, so again, that was from my notes from lesson 100. So if you don't have those, as I keep reminding you, please make sure you guys do make some notes because this will be very helpful to you later on. Then we're going to move on to number 12, and this is going to be graphing the absolute value, which is from lesson 99. So I'm going to start by just solving for that inequality. I see that there's a slash through my inequality symbol, so what I'm going to do first is I'm going to flip that, and I'm going to add the equal sign back in. Then I'm going to add 4 to both sides. So I have negative absolute value of x is less than or equal to 4. Then when I divide by negative 1, remember that you have to flip this inequality. So that would become the absolute value of x is greater than or equal to negative 4. And remember, integers are going to be dots, not going to be an arrow. So then I go to my notes and I look at the, for lesson 99, and it says there are no absolute values that are less than 0. So there are no absolute values that are going to be less than a negative number. But for an absolute value that's greater than a negative number, the answer is going to be any number. Okay, so for this one, our answer is just going to be any positive number. So our number line, we could set up like this: 0, 1, 2, -1, -2, and since it's just integers, we would just fill in all of these dots because our answer is going to be any number because of this negative sign. So anytime you see an absolute value and a negative sign, you're going to want to flip back to your notes because that's going to be a key point that you need to look up, because it's either going to be any number or it's going to be all numbers. Now moving on to number 13. This is from lesson 98. And remember this formula here: number is equal to the first plus the fraction times second minus the first. The order in which it shows up in the word problem is going to be fraction first second. So I'm going to start by writing this out. So it'd be the number is equal to the first, which would be 3 1/3, plus the fraction, which is 1/10, times the second, 6 1/2, minus the first, which is 3 1/3. I'm going to start by just making those all into improper fractions. So this would become 10/3 plus 1/10 times 13/2 minus 10/3. I'm going to make a common denominator in here, multiplying this by 2 and this by 3. Everything else I want to leave the same. So 10/3 plus 1/10. That would turn into 13 times 3, and then minus 20, which would give us 19. So 19/6. Now I'm going to multiply this. I'm going to leave the 10/3. So 10/3 equals plus 19/60. So the common denominator is obviously going to be 60. So I'm going to multiply this by 20. So that would become 200/60 plus 19/60. So 219/60. And that written would be 3 13/20. And this right here could be simplified. So this would actually be 73/20. This would be one of your answers or one of your answers. Now we're going to look at number 14. So the first thing that I'm going to do for number 14 is going to be to multiply this equation right here by 20. The bottom equation, I'm going to have to multiply by 1,000 to get rid of all of the decimal points. So this one, the top one, I'd multiply by 4, so that would be 12x minus 5y equals 100. Bottom equation would turn into 12x plus 70y equals 2,200. I'm going to do elimination, so I'm going to multiply this equation by -1. Bottom equation stays the same, so it'd be -12x plus 5y is equal to negative 100. So when I add those together, I'm going to get 75y is equal to 2100. And when I divide by 75, I get y is equal to 28. And then I'm going to have to solve for x. So I'm going to take that and I'm going to plug it in to probably the top equation. So that would be 12x minus 5 times 28 equals 100. And then 5 times 28 would be 140. So I'm going to add 140 to both sides. So that would be 12x is equal to 240. Which means that x is going to be equal to 20. And then lastly, we're going to look at number 15. So for number 15, I'm going to start by solving the top equation for y. When I do that, I'm going to bring the y to the right side and bring the 3 to the left, which would make this y is equal to 5x minus 3. I'm going to plug that in, so that would be x times 5x minus 3 equals 4. If I distribute that, I get 5x squared minus 3x minus 4 equals 0, because I'm going to set it equal to 0. Now I'm going to solve for x by not completing the square. I'm going to do quadratic formula. So x is going to be equal to negative b plus or minus the square root b squared minus 4 times a times c all over 2 times a. So two negatives are going to make a positive. That would be 3 over 10. This would turn into, so 4 times 5 times 4 is 80. And that would be plus the 9. So it would be the square root of 89 over 10. Okay, and that's going to be your result for x. So x is going to be equal to 3/10 plus or minus the square root of 89 over 10. Then what we're going to do is we're going to solve for y by plugging that in. So y would be equal to 5 times this whole thing. So 3/10 plus or minus root 89 over 10 minus 3. And we're going to distribute that. So that would become 3 over 2 plus or minus root 89 over 2 minus 3. And I want to combine the 3 and the 3 over 2. And that would be negative 6 plus 3. So that would be negative 3 over 2 plus or minus the square root of 89 over 2. And that would be your result for y. And that concludes all of your questions from lesson 106A. I hope you guys all have a great day. Bye.